Ratio and proportion is a super common and easy to score topic. You will see this in word problems, geometry, and even data interpretation questions. Let's break it all down step by step. Ratio compares two quantities. Writing two numbers as a ratio provides a convenient way to compare the sizes. Also, it tells us how many times one value contains the other. A ratio can be a part-to-part ratio and a part-to-whole ratio. So if we simply say A is to B or A over B, that's a part-to-part ratio. And A over A plus B, the sum of the combined ratio values would be a part-to-whole ratio, which we also call a fraction. For example, if the ratio of boys and girls in a class is 3:2, that means for every 3 boys, there are 2 girls. A ratio can be expressed in either a decimal or a fraction form. Please do not write 3:2 or 3:2 in your as your answers in the student response questions. That would be considered as a wrong answer. So please type ratio answers in either a decimal or a fraction form. Let's learn a quick fraction strategy for ratio problems. It helps you find any part of a total fast. For example, a paint contains 2 parts of blue paint and 3 parts of yellow paint. So the ratio of blue to yellow paint is 2:3. Now the total mixture is 70 gallons. So now to find the amount of blue paint, we will execute the fraction strategy. The first step here is to find the total parts in the ratio by simply adding the ratio values. So 2 plus 3, it is 5 parts. So that's the total 70 gallons. Now divide the ratio of blue paint over the total parts. So we get the fraction 2 over 5. So the fraction of blue paint is 2/5. Now multiply the fraction with the total amount in gallons to get the number of gallons of the blue paint. So this way we could easily solve the questions on ratios to find the actual values. Here is a SAT tricky ratio question. Now, when you need to find the combined ratio when 2 or more ratios are given, first we need to find the LCM of the common ratio terms. Here, the common term is B in both the ratios. So we need to find the LCM of 3 and 5, which is 15. Now we multiply the first ratio by 5 and the second ratio by 3 so that the B value in both the ratios is same. Now we can combine both the ratios. So the combined ratio A to B to C would be 10:15:21. So finding the LCM is the key idea here. Now, the common mistakes we do are swapping the order. So please remember A to B is not same as B to A. And please always sum the ratio parts before you do the scaling or you do the fraction. Now you also can cross multiply to easily solve the direct proportion questions. And sometimes when there are exponents involved in a hard ratio proportion question, so don't forget to include parts in the formulas. And please be careful with the units. So see that the units are consistent across all the fractions. That's how we are not going to make any silly mistakes and improve our accuracy. More apples, more cost. That's direct proportion. In direct variation, if one value increases, the other value also increases. They change in the same direction. So we can denote that relation as y equal to kx. And for direct variation, you can apply the formula x1 over y1 equals x2 over y2. For example, if y varies directly as x, and we have a pair of values, y is 10 when x is 5, then to find y when x is 8, we can apply the formula. So 5 over 10 must be equal to 8 over y2, and you can cross multiply to get the required answer. Similarly, we do have inverse proportion. In this case, when x increases, y decreases. For example, if there are more people working, then they take less time to finish the job. So we can denote the relation as y equals k over x. Now, the formula here is x1 y1 equals x2 y2. So that's your fast solving trick. And here we have another example. Now, if y varies inversely as x, and we have a pair of values, y equals 12 and x is 3. And now to again find y when x is 6, we apply the formula x1 y1 equals x2 y2. So 3 times 12 must be same as 6 times y2. Now we can further simplify and get the answer for y2 as 6. So please use the direct and inverse proportion formulas whenever you come across a proportion question in the ACT.